In Module 7, we introduced the Consumer Price Index for Urban Consumers time series since 1965 as an example of a time series with trend as its primary component. We then fit least square, linear, quadratic, and exponential trend models to the Cpi U time series with moderately good results. For example, the MAD for the linear trend model was 3.56%. We begin Module 8 discussing the definition of the Cpi U and two common applications of the Cpi U. Here's the idea behind the computation of the Cpi U for a particular month. A month is the basic period for computing a Cpi U value. To begin with, a market basket of 400 commonly purchased items is identified. Next, a typical number of units purchased of item I during the 1982-84 base period is identified. This quantity is referred to as Qi0, and it appears twice in the calculation. Then, the average unit price of each item during the 1982-84 base period is identified. This price is Pi0, and it appears but once in the calculation. The denominator consists of a sum of the price of item I during the base period times the quantity of item I during the base period. The sum being over all 400 items in the basket, the denominator is the price of the basket pegged to the base period. Thus, the denominator, the price of the basket in the 1982-84 base period, is the same for the calculation of all Cpi U monthly values. We now focus on the numerator. We determine the price of item I in month T. We multiply that price times the quantity of item I purchased in the base period, and then add up those products over all items in the basket. The numerator is the price of the identical basket, but in month T. The ratio of the month T basket price to the base period basket price is a Cpi U for month T. For example, the Cpi U in June of 2013 was 233.5. That's 233.5%. That says that the price of the market basket is 233.5% of what it was in the base period of 1982 through 1984. We proceed to two common uses of the Cpi U. The first involves converting a given period's dollar amount to an equivalent, in terms of purchasing power, dollar amount in another period. This result drives the application. It says the period J dollar amount with equivalent purchasing power to Y dollars, and that Y dollars being in period I, is obtained by this expression. The CPI for period J divided by the CPI for period I times the Y dollars in period I. For example, $10 in 1980 would have the same purchasing power in July 2013 as the CPI for July 2013 divided by the CPI in 1980 times the $10 in 1980, etc. We have moved to the next page, where there are 2 U-try exercises that you should complete. You can check your answers by pulling down the text boxes. We have moved to the next page. The second common use of the Cpi U is to compute the amount of economic inflation. The amount of economic inflation between the jth and the ith period is computed as the relative rate of change in the Cpi U between those 2 periods. The relative rate of change between the jth period and the ith period, where the jth period is considered the earlier period, is the difference between the Cpi U in the earlier period and the Cpi U in the later period divided by the Cpi U in the earlier period. Since the amount of inflation is generally expressed as a percent, we multiply this relative rate of change of the Cpi U by 100%. Here are 2 U-try class exercises, parts A and B, that you should complete. On this next page, we have used the annual Cpi U quantities in years 1965 through 2012 to compute the annual inflation rates. We have done that by asking Excel to compute the relative rates of change in the Cpi U from one period to the next. We have identified the relative rate of change in the Cpi U from 1965 through 1966. The 2.86% quantity, we have identified that with year 1966. We've identified the relative rate of change in the Cpi U from 1966 to 1967. That is the annual inflation rate with 1967, and so forth. This next table is just a modified version of the earlier table. In this table, we have computed the average annual inflation rate between 1966 and 2012 to be 4.35. And then we've placed that average inflation rate of 4.35 in every cell in column E down to the 49th cell. And on the next page, we will do a simultaneous scatter plot, simultaneous time series plot really, of the annual inflation rates versus the average inflation rates. On the next page, we see the simultaneous time series plot of annual inflation rates versus the average inflation rate. We can see, for example, that prior to 1982, the annual inflation rate was primarily above 4%, and after 1983 was typically below 4%. A final comment about the annual inflation rate series. The series itself appears relatively stationary, with no long-term trend component. If we desired to model the annual inflation rate series, we would try a smoothing method. This will end this screencast.